CSEC students, welcome to another live CSEC class. This evening we're going to look at how to solve linear equations. So before we go into that, I'm going to play for you our schedule of live CSEC and PEP classes. Remember, we have 6 live CSEC classes every week, and we also have 5 live PEP classes every week. So I want you to watch the schedule. I want you to write down the times and the days and what is done on each day so that you make sure you don't miss any of the sessions. You make sure that you stay on top of things and get yourself ready for your CSEC exam. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. No, another important question. Have you done a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of times. In this series, we're going to be looking at the common mistakes that students make with all it in CSEC math. We're going to look at errors, demystify everything. Make sure you watch every video in this series so that you avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true. We're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, scholars, let's go. So we are going to solve linear equations. A linear equation will have a variable with the highest power of 1. That means you're only going to see x or y or w, whatever the variable is. You're not going to see x squared, y squared, x cubed, and so on. We're going to solve linear equations that have one variable. There are methods for solving linear equations with more than one variable. So we're focusing on one variable. So that means in the equation, you're only going to see x as the letter or the symbol. You're not going to see x and y or x and w or a and b. It's just a in addition to maybe some whole numbers, some constant terms, but in terms of the variable, only one variable. I'm going to invite my scholars to join me on screen. I have my faithful studio crew. Welcome, Imani. Welcome, Asar. Hopefully some other scholars can join us a little bit. And also we have John and Amari joining us So let's share the screen so we can get to it. So we're solving linear equations. Now there are a number of pointers we need to remember when we're solving linear equations. We need to remember that we want to isolate the variable. We want the variable by itself. And preferably, we want the variable on the left-hand side if possible. Second point is, in order to isolate the variable, we will have to do the opposite operation of whatever the operation is we were given originally. So that means if we are adding something, originally we got an addition, and we want to remove that term from either the left or the right, we are going to subtract the term from both sides of the equation. Whatever you do to one side of the equation, you're going to do it to both sides of the equation, because you don't want to change the actual value of the equation. We don't want to be multiplying one side of the equation by something and not the other side, because then we are going to completely alter the value of the original equation. We're going to start with some simpler equations and then step it up a notch to some more complex ones. But these pointers that I'm telling you, they apply to all of them. So here we go. So we have question 1. Three x plus 5. What's happening? 3x plus 5 is equal to 11. What's up with my mouse? I'm not sure. It's not writing properly. All right. So we want to isolate the variable. The variable here is x. At the moment, it is attached to the 3. So the easiest thing to do for now is to remove the 5 from the left-hand side. So we're adding 5. So we're going to do the opposite of that, which is to subtract 5. And we have to do that from both sides. So what we're left with there, plus 5 minus 5, that's gone. That has been 5 minus 5 is 0, so that's gone. So we have 3x on the left, and then 11 minus 5 is 6. So now we don't want 3x, we want x. So here we're multiplying 3 and x, so we need to divide by 3, and that will cancel out the 3, and we need to do the same on this side. So what we're left with is x is equal to 6 divided by 3, which is 2. So x is equal to 2. If you have questions, please post them in the chat, or for those in studio, just let me know. All right, so Asar, I'm going to ask you to walk me through the next question. Tell me what to do.
Miss, can you go back, please?
Padme, you want me to go back?
Yes, miss. Yes, miss.
All right. So originally we had 3x plus 5 is equal to 11. And we said we want to isolate the variable. The variable in this case is x, and it is now attached to the 3. It's 3 times x. So the first thing that we do is to get rid of the 5 from the left-hand side. Since we originally were adding 5, in order to get rid of the 5, we need to subtract 5, which would make 0. But we have to do that to both sides of the equation so that we don't change the actual value of the equation. It's still as it was. If we take 5 from one side, take 5 from the other side, the value of the equation remains because we have done the same thing on both sides. So when we take 5 from 11, we're left with 6. So we now had 3x is equal to 6. Now we need to get rid of the 3 because we want x.
By itself.
So here we're multiplying x by 3. So we need to divide by 3 to cancel out the 3. And we need to do the same thing on the right-hand side. Divide the 6 by 3. So now we're left with x is equal to 2. When we're solving for variables in algebra, it's always a good idea when you get your solution to plug that solution back into the original equation and see if it adds up, see if it makes sense. So we had 3x plus 5 equal 11. So if x is 2, would that make sense? 3 times 2 gives 6, and 6 plus 5 does give 11. So our answer is correct. Do you understand?
Yes, miss. I understand.
All right, so Asar, this one is for you, question 2.
Okay, miss.
And we have negative 4y plus 10 is equal to negative 22. So walk me through it and tell me what I'm to do.
First, you want to get rid of the 10 by
Speak up a
subtracting.
little louder, please, Asar.
First, you want to
Speak
get rid of
up a
the
little.
10 by subtracting 10
Uh-huh.
on both sides.
Okay, so we're adding 10 now, so we need to subtract 10 from both sides. And when we do that, what are we going to have?
Negative 4y equal negative 32.
So this plus 10 minus 10 now gives 0. We can count. And negative 22 minus 10 is negative 32. Okay.
Then
So
then
what
you have to
next?
divide both of them by negative 1.
Is it why do I have negative 33? It's negative 32. All right. Negative 32. Divide both of them
Negative 1.
by negative 1. Why are we doing that?
So we can get both of them to be positive.
All right, but can we do something else and just get rid of the negative 4 in one step?
Yes, miss, but I was just showing the process.
All right, so okay, so you're saying divide them both by negative 1. So we'd end up with 4y equals 32. All right.
Then divide both sides by 4.
All right, so divide both sides by 4, which will cancel out that 4. All right. And what will you be left with?
Y equal 8.
All right. So y is equal to 8. And that is our solution. So test it back into the original equation and see if it adds up.
Negative 4y times 8 plus 10 equal negative 2.
You said negative 4y, but you're not to say the y now.
Neg-
You are to plug in the 8. So it will be negative 4 times 8. And that would give what?
negative 32.
Mm-hmm.
And then when you
Continue,
add
just
that,
prove.
then when you add
Yeah,
that to
you're
10,
just
you get
proving that your answer is correct. So you're saying negative 4 times 8. If we're saying y is 8, that would give negative 32. And when you add that to 10, you do get negative 22. All right, Amari, your turn. All right, Amari, this is question 3. So we have 15 plus 2w. And that is equal to negative 1. So 15 plus 2w equals negative 1. Walk me through it, Amari. What am I to do to solve for w?
Miss.
Could you speak up, please, Amari?
Um,
Amari, are you there?
yes, Miss.
Go
Miss, you,
ahead.
Miss, you carry over the Miss the one, Miss the negative one.
I'm not hearing what you're saying.
Miss carry over the negative one, Miss.
So you're carrying over the negative 1. And so I'm going to put 15 plus 2w minus 1.
Yes, Miss.
That's what I should have.
Yes, Miss. Yes, Miss.
15. So you're saying 15 plus 2w
No, wait.
minus 1. And what
If you,
else?
if you say no now, Miss, Miss, you wouldn't put down.
So what
Miss,
would I put?
Miss carry, Miss carry, Miss
What would
would
I put?
15, Miss. And then Miss you would put 2
I'm
W.
sorry, Amari. I'm not hearing what you're saying.
Miss you would carry the 15. And her
You would carry the
and
15.
you would have 2W Miss equal negative 1 minus 15, Miss.
So you're saying carry the 15 across to the right hand side. Since it's a positive 15, when we bring it across, it's now going to be a negative 15, right?
Yes, Miss.
Okay, so that's one way of doing it. So 2w is equal to negative 1 minus 15. All right, so what next?
Miss next you would give me a second, please.
Remember, we want everyone to hear what we're saying, right? We want those who are watching to hear what is happening, not just to see what's happening.
Miss, divide negative 16 by 12, miss.
Okay, so first we need to write that
Oh, by 2, miss.
negative 1 minus 15 is negative 16. And then what?
Miss, you're going to divide negative 16 by 2, miss.
And what do we do with this 2 here? So you're saying since we're multiplying 2 and w, we want to get rid of the 2, so we do the opposite, which is to divide by 2.
Yes, miss.
So w would be negative 16 divided by 2. And what is that?
Miss, negative 16 divided by 2, miss. That's negative 8, miss.
All right, negative 8. Okay, thank you, Amari. Your turn, John. So this is question 4.
Okay.
And we have negative 18 minus 3r is equal to negative 39.
Okay, miss. So, miss, we're going to bring over the negative 18 as positive 18.
So you remove the negative 18 from the left and bring it over here. It's going to become a positive 18, which is what we're really doing is adding 18 to both sides. So that would have canceled and we're going to add 18. So we'd have what left back now over here?
Miss, miss 18 from 39, miss. Miss,
On the left hand side, what would we have?
miss on the left hand side, miss, would have 0, miss. Miss,
We'd have,
sorry, miss 3. Negative 3 are,
all right, so we'd have negative 3r is equal to, and we'll
negative,
write back the negative 39. And then you're saying the negative 18, when we cross it over, it will become a positive 18.
yes,
Or we're adding 18 to both sides then. All right, what do I do after that?
miss, after that, miss, we try to get rid of the 3 are, miss.
Negative 3r.
Yes, miss, we try to get rid of the negative 3 are,
But why
miss.
not work this first? Tell me what this gives you first.
Miss, that would give you negative 21, miss.
All right, so negative 39 plus 18 is negative 21.
Yes.
All right.
Okay, miss. And then we would come to both the negative 3 or the negative 21.
Okay,
Right.
so we'll divide both sides by negative 3, you're saying,
Yes,
and that will be gone.
yes.
So what is negative 21 divided by negative 3?
Miss 7.
Negative or positive?
Oh, I'd say it's positive 7.
All right, so when we divide a negative number by another negative number, the answer is positive. So plug that value back into the original equation, John,
Okay,
and
miss.
tell me if it makes sense.
Negative 18 minus negative 3 times 7. That's
So negative 3 times 7 would have given
Miss 21. Oh, Miss negative.
negative 21. So we'd have negative 18 minus 21. And does that give 39?
Yes,
All right. Imani, you're up.
yes, miss.
All right. So this is okay. So this is question 5, and we have 15 over x is equal to 70. 15 over x equal to 75.
Okay, miss.
How would you approach that?
So, miss, we're going to multiply the 15 over x by x, x over 15. Miss, since we want to get what x is.
You're multiplying the 15 over x by x over 15, but that would give 1.
Sorry, by 1 over 15. Sorry.
Okay, so basically, so what would we have?
Miss, wait. Um,
So bear in mind, this is 75 over 1. So whenever you have an equation lined up like that, where the terms are lined up, we can cross multiply.
oh, yeah.
This times this is equal to this times this. So what that would mean is 15 times 1 is equal to 75 times x. All right, so can you take it from there? So 15 is
Yes,
equal
miss.
to 75x. So where do we go from there?
Miss, we're going to divide both sides by 75 to get x by itself.
All right, so divide both sides by 75. And what will happen on the right?
Miss, um, the same thing. On the right, we're going to have x by itself.
So this would cancel and we're left with x. And what would happen on the left?
Miss, we can cancel it down to 1 over 3.
1 over 3.
Sorry, 1 over 5.
Okay, so 15 goes into 75 5 times. So we have 1/5. X is 1/5. We can leave it like this, but we like to put the variable on the left when we have solved. Just rewrite it with the variable on the left.
So x
X is equal
equal
to
1 over 5.
1/5. Okay. All right, your turn. 6. Number 6 says x over 9 is equal to 36. So walk me through that, Asai.
The first thing you want to do is get rid of the 9 at the bottom.
Mm-hmm. And how do we do that?
Or actually, you could divide the 36 and the 9 by 4. Wait, no. By 3. So
No,
x,
no, you can't. No, you can't do that.
1 second.
So remember, this is over 1. Remember what I just said about when they're lined up in this way, what we can do. So we have x over 9 is equal to 36 over 1.
So x is equal to 36 times 9.
Right, so we cross multiply x times 1, which is x, is equal to 36 times 9. And how much is that?
324.
All right, so x is 300 and what?
324.
So 9 sixes 54, 9 threes 27, plus 5. You mean 324. Okay. All right. So who is next? John? So we're going into some more complicated ones. No. So we're at number 7. A little more complicated. So we have negative 2 x plus 7 and that's equal to 4 x minus 8. Take it away, John. Tell me what to do.
Going to write the bracket first.
Why am I not hearing my scholars tonight? Why?
Miss, we're going to write the bracket first, sorry.
All right, so let's expand the brackets. So what do we say?
Miss, we're going to multiply the 2 times what's in the bracket. Miss, it be
Is that 2?
Miss negative 2. Miss negative 2.
All right, so it's negative 2 times both terms in the bracket. All right.
Yes.
So negative 2 times x would give
Miss negative 2.
negative 2x. And negative 2 times positive 7.
Miss, that would be negative 14.
All right, so now we go over to the right-hand side, and what do we do?
Miss, we multiply the 2 terms in the bracket by 4. Miss.
So everything in the bracket, the 2 terms, the x and the negative 8, we're going to multiply by 4. So 4 times x.
Miss, 4 times x is 4x.
And 4 times negative 8.
Miss, 4 times negative 8. Miss, that's negative. Oh, Miss, sorry, Miss, that's 32.
Negative or positive?
Miss, negative 32.
Because we have a positive 4 times a negative 8. All right, what do we do now?
Miss, we put Miss we put the same values together. Miss too.
So we're grouping the like terms. That's how we say.
Miss Amanda, us how to say it.
So I'm telling you how to say it.
Yes.
That's what I'm doing. I'm telling you how to say it. So next time, that's what you say, right? We're grouping the like terms. And what do we mean by like terms?
Miss, for example, the 2x and the 4, Miss,
The
the one
negative 2x and the 4x.
yes.
What makes them alike?
Miss the x, Miss.
So they both have an x. So we're going to group the like terms. And which other terms are alike?
Miss the 4, Miss the negative 4, Miss the negative 14 and the negative 32.
And what do we call those terms?
Miss negative numbers.
Negative numbers, or they are constant terms. They don't have any variable, or we could say they have a variable that has a power of 0.
Yes.
So we're grouping the x's. So are we pulling the x's to the left or to the right? We can do either one. It's up to us. Where you want to pull the x's, to the left and the whole numbers to the right?
Miss the x to the left and the whole numbers to the right.
All right, so that means we'd be left with the negative 2x, and we're going to bring this 4x across. It's going to become negative. Am I right?
Yes, Miss.
What else do we do?
Miss, we bring over the negative 14, Miss, and we'll bring it over as positive 14.
All right, so the negative 32 stays on the right.
Yes.
To move that negative 14 across the equal sign. And once we're doing that, the sign will change. So it's going to become a positive 14. Or we can say we are adding 14 to both sides. That's another way to say it. So we're adding 14 to the left, that cancels out, and we're adding 14 to the right. So what's the negative 2x minus 4x? That gives what?
Miss negative 6x.
All right, so we have negative 6x on the left. And how about on the right?
Miss negative 32 plus 14. Miss that gives negative 20.
Negative 32
Oh,
plus 14, that gives what?
Miss that gives negative 18.
All right, negative 18. What do we do now?
Miss, we divide the negative 6x by 6 by negative 6
All
and
right,
negative
so we divide both sides by negative 6, and that cancels. So what's negative 18 divided by negative 6?
Miss that would be 3. Miss positive 3.
Positive 3. So plug that back into the equation, John.
Okay. Yes. Okay. So negative 2 times 3, that negative 6. Negative 6 plus negative 14 equals 4 times. Okay, so the 4 times the 3 would give you 12.
What answer you get on the left when you do that?
Miss you would get negative 6 plus negative 6 minus 7.
No,
Minus
you
14.
get negative 6 minus 14, which is what?
Miss that would be negative 20.
All right, and when you plug in 3 on the right, what do you get?
Okay. Miss you get 4. Miss
You get 4 when you plug.
Miss.
You sure? When
Oh
you
no
plug
no
in 3,
no no. Miss I forgot to do the 8. Miss.
uh,
Okay. So miss that would be negative 20. Miss. Negative 20.
so we'd have 4 3s 12 minus 4 8s 32. Or we could just plug in the 3 in the brackets here, and 3 minus 8 is negative 5 times 4. So we'd get negative 20 on both sides.
Yes.
So they are equal. That's how we know. All right, Imani.
Okay, miss.
So we're at number 8. And we have 3 and x plus 2 and plus 9. So this one is a little longer. So that's equal to negative 3 and x plus 5. All right, so let me check that. Give me a second. Let me check my chat and see what's up. All right. We have Jamani's here. Dinsmore is here. Good night, everyone. All our regular and newcomers, our regular scholars, and our newcom. And thank you for joining us. For those who are joining us on YouTube, Facebook, and Twitter, and wherever else in the universe you are, welcome. We appreciate your company. Remember to post your answers. Those in the chat, do your working out, post your answers, and see if you get the same thing that we get. That's one way of testing that you understand what you're doing. Okay, Madam Imani, let's continue.
Okay, miss.
First, we're going to work the brackets or use distributive law to solve them. So 3x, 3 times x is 3x, and 3
All right.
times positive 2 is positive 6.
All right. So we're expanding using the distributive law, and we'll write back the 9. What else do I do?
Plus 9. And rather bracket, which is negative, which will give us negative 3x minus 9.
So negative 3 times x is negative 3x, and negative 3 times 5 is negative 15. All right. So what do I do next?
Miss, now we're going to group the like terms. So we're going to bring over the negative 3x to make it a positive 3x. So
Or we could say
3x
we're
plus,
adding 3x to both sides, right?
yes, miss.
All right. So we'll have 3x. Can I combine these two same time? 6, 9.
Yes, miss. That would give
All
us
right. So that
positive
would give 15. And I no longer have this negative 3x because that is now cancelled. So I'll have negative 15. Okay, what next?
miss. So we are going to we can add the two 3x's. So 3x
Mm-hmm.
plus 3x is 6x, and we can subtract 15 from both sides to have
All
the
right.
x value on one side.
So we'll have negative 15 minus 15.
Yes, miss.
Okay.
And that will give us 6x equals negative 30. And what we're going to do, oh, yes, we have to put the negative 30.
Mm-hmm.
We're going to divide both sides by 6 to get x
Okay,
by itself.
great. All right. So divide both sides by 6, which will cancel this one.
Yes, miss. Miss, we're left with x equals negative 5.
So negative 30 divided by 6 is negative 5. All right. So you know what we're in the solution and
Oh,
check if it makes sense. So do that for me, please.
okay, miss.
Walk me through it.
Oh, okay. So we're going to substitute the x values in the original equation to negative 5.
Mm-hmm.
So 3 times negative 5 is
Hold on.
negative 50.
You can't if you're substituting the negative 5
Oh yes,
in the bracket, you can just do it in the bracket and then you multiply that by 3. That's an easier way to do it.
miss. Repeat please.
You can, I'm saying, rather than say 3 times negative 5 plus 3 times 2, you can just plug in the negative 5 where x is and work the negative 5 plus 2 and
Oh
then
yes.
multiply that by 3.
So that would give you negative 9 plus 9, which is 0. And then that would also give um so in the first bracket, negative wait. Okay, in the first bracket, since we're substituting negative 5, it's going to be negative 5 plus 3, sorry, negative 5 plus 2, which is negative 3, and
Mm-hmm.
it's going to be negative 3 times 3, which is negative 9. I'm going to put back the plus 9 equals, in the second bracket it would be negative 5 plus 5, which is 0. So negative 3 times 0 is 0, and it would give us 0 equals 0. So
All right, so we have zeros on both sides, so we know we're correct. Okay, Asar, your turn. And we're at number 9. 3 more to go after this one. So that's 5. 3 minus y. And we have minus 2y equals 86. All right, Asar, walk me through this one.
First, you have to expand the bracket.
Mm-hmm.
So 5 times 3 is 15, and
Okay.
5 times negative y is negative 5y.
Okay.
Minus 2y equal 86.
Mm-hmm. All right.
And then since negative 5y and negative 2y have the same variable, you can
Mm-hmm.
subtract them.
All
So
right.
negative 5y minus 2y is negative 7y
Okay.
equal 86.
Mm-hmm.
And then you carry over the 15 and
All
subtract
right.
it from the 86.
Or we can say we're subtracting 15 from both sides. So that's 86, 15. Okay, so what? So
And then
let's work that on the right. That would give us what?
71.
Okay, 71. What next?
Then you say y equals 71 divided by negative 7.
Okay. And y is?
Y is equal to negative 10 and 1 over 7.
Okay, negative 10 and 1 over 7. All right, so we got a fraction, which is allowed, that's perfectly fine. You can substitute it back. It would take some, you'd have to work it. You can either work it as a decimal or as a fraction. So negative 10 and 1/7, substitute it into where y is. So 3 minus negative 10 and 1/7, and then you multiply that by 5, and also substitute a negative 2 times 10 and 1/7. So let's see, let's check over here.
So y
So I'm
is
going to
equal
work,
to
so I'm going to substitute. So we'd have 5, and we'd have 3 minus 71 over 7 minus 2 times negative 71 over 7. So this part here would give us what? Positive 2 times 71 is 142 over 7. And this here would give 5 3 is 15 minus, and 5 times 71. 5 ones 5, 5 sevens 35 over 7. All right, so let's put this over 1. And LCM, of course, would be 7. So 1 equals 7. What's 15 times 7?
100 and
Hmm?
105.
105. And 7 into 7 is 1. So that's about the negative 355. And 7 into 7, 1, which gives back the positive 42. All right, so we have 105 minus 355 plus 142. 2 ones 2, 2 sevens 14, 5 threes 15, 5 ones 5, 5 sevens 35. All right, let me see if I did that properly. So 15 times 7. All right, so let's retract. So we have the 5, 3, negative 71 over 7, that's y, minus 2 times negative 71 over 7. And expanding this, so we have 5 threes 15, 5 ones 5, 5 sevens 35, and 2 ones 2, 2 sevens 14. So these should add up to 86. 1 into 7 goes 7, 15 times 7, 105, minus 355 plus 142. So I'm getting negative 108. All right, so let's retract from up here. 5 3 is 15, 5 times y, negative 5y, minus 2y. And then we have minus 5y minus 2y, that's minus 7. 85 minus 15. 86 minus 15. That's 71 divided by 7. So I'm not seeing why it's not adding up here. We should get back 86. All right, so look at it and see if we can figure out at what step we went wrong. We have the 5, we have the 3 minus y, which is negative 71 over 7. And we have the negative 2 times y, which is negative 71 over 7. Do you see where we're going wrong here? I'm not seeing.
Miss, 3 times negative 71 is negative 213.
3 times negative 71.
Yes, miss.
But where would we do that operation? It's 3
Oh,
minus,
3 minus.
yeah, 3 minus. And if we work, let's say we work the brackets. So 3 over 1 minus 71 over 7. 3 sevens 21 minus 71, that would give negative 50 times 5. So that's negative 250. Negative 250 minus minus 141. I'm still not getting it. 140. Still not getting it. All right, so we can come back to this, or we can do it at another point and post the answer in the chat. So we have, so that was what, number 9. All right, so let's go to number 10. Okay, so John, this is yours. Okay, so we have -2 4 plus y minus 5 equals 80 minus y. Okay, so walk me through this.
Okay, Miss, we're going to write the brackets first. Miss -2 times 4, Miss, is -8. A -2
Okay.
times +y, Miss. Miss, that's -2y.
All right, so we have -5, and on the right we have 80 minus y. All right, so what do I do? What do I do from here?
Okay, Miss. Miss, your Miss, your group, you like terms?
So which terms are alike in this?
Miss, the 2y and the y, Miss, the 2y and the y.
Okay, so can we combine the -8 and the -5 from over here?
-8 and -5. Yes, Miss.
Okay,
Yes,
so what would that give?
Miss, that would give positive. Oh wait,
Positive?
no, sorry, Miss, that would give -13.
Okay, so -13. And we'd have -2y and 80 minus y. All right, so you're saying now we're going to group the y's together. Are you going to bring them to the
Over, yes,
left?
yes,
Okay,
Miss.
so we'd have -13. Walk me through it.
Okay, Miss, -13 minus 2y plus y equals
Okay,
80.
plus y. All right, what is y?
Miss, that would give 3y.
-2y plus y.
Miss, y, sorry, y. That gives y.
Is it positive or negative?
Let's, Miss, -y.
All right, so we'd have 13 minus y, and that gives 80. All right, so where do we go from there?
Oh, yes, yes. Okay. Miss, you'd bring over the -13.
All right, so that means we'd still have a negative y, and then on the right we'd have 80. So if we bring over the -13, we have now.
Miss, a +13.
Okay, so when we add it to the 80, what do we get?
Miss, from add that to the 80, Miss, we get 3.
Okay, so negative to 93, but we want negative y, we want y.
Oh, okay.
Okay, so what do we do from here? How do we get y
Right.
instead of negative y?
Miss, you do negative y by Miss, you use y. divide negative y by y.
So, so what we need to do is to divide both sides by -1.
Yes.
Okay, so that will give a positive y, adding that by -1, so we'd end up with y equals,
If y equals 93.
no, not 93.
Miss negative 93.
All right, so plug this back into the original equation and
Yes.
see if it adds up. So we're plugging in -93 where y is, and we should have the same thing on both sides.
Okay. Okay. So Miss negative 2 times 4 that's negative
No,
8.
don't do it like that. Plug in the -93 first in the bracket and add it to what's in the bracket. So
Okay.
it'll be 4 minus 93,
Okay.
and
Okay.
that
So
will give
Miss 4 minus 93. Miss
mm-hmm,
that would give negative 97.
-97. Mm-mm.
Oh. Miss that would give negative 89.
Okay, and then we're going to multiply that by the -2.
Okay, Miss.
It will give what?
176.
78.
Okay. 78.
Um, and -5.
And minus 5. 109, 175. 73, sorry.
Okay, 173. All right. So now we need to do the same thing on the right hand side. So it will be 80 minus -93, which will be the same as 80 plus 93.
Okay. Yes, Miss.
All right, so that gives what?
Miss, that gives 173.
Okay, so we know that we're correct because we get the same thing on both sides. Same thing on the left, same thing on the right. All right, so Asar, no, it's Imani.
Yes, Miss.
Imani and then Asar. So this is number 11. And we have 3y plus 8 minus 6y plus 9 equals 41. Okay, so walk me through this, Imani.
Okay, Miss, so the first thing we're going to do is group the the like terms. So 3y minus 6y plus 8 plus 9 equals 41.
All right, so okay, so we're putting the like terms together. So we have 3y minus 6y, and then we'll have plus 8 plus 9
Equals 41.
Okay, so that gives 41. All right, so when we combine the 3y and the 6y,
Miss, we get negative 3y
so negative 3y,
and 8 plus 9 would give us positive 17.
okay. Mm-hmm.
So now
Equals
equals 41.
41. All right,
So now we're going to subtract 17 on both sides to get the negative 3y by itself. Well, we're working
so
to
we'll
get the
end
y
up
by
with,
itself.
all right, so we'll end up with negative 3y
Negative 3y
equals,
equals 24.
well, let's write this first. 41
41 minus
minus
17.
17. And that gives what?
Miss positive 24. So negative 3y equals 24.
Okay, so that means y is,
Miss, that means y is negative 8
so we're going to do what? We're going to divide the 24
by negative 3.
by negative
Divide the
3.
negative
Okay,
3y by negative 3.
all right, that's negative 8. All right, plug that back in and see if you end up with this on both sides.
Okay, miss. So 3 times negative 8 minus 6 times negative 8. So 3 times negative 8 is negative 24.
Mm-hmm.
Negative 8 times negative 6 is positive 48 plus
Mm-hmm.
17. So equals 41. I keep forgetting that. So 48 plus 17 would give us 65. So it would be negative 24 plus 65 equals 41. And we would carry over this 65, which would
No, no,
give,
no,
which would,
no, Imani. I'm saying plug them in the left and see what you get and see if it's equal to 41. Plug in the negative 8 on the left wherever you see y, expand it, combine them and see if you get the 41. So 3 times negative 8, that's negative 24. And
yes,
we'd have
miss.
plus 8. And negative 6 times negative 8 is positive 48 plus 9. So when you add those up, negative 24 plus 8 plus 48 plus 9.
Oh,
Do
sorry.
you get 41?
Negative 20. Okay, I see what you're doing, miss. Okay. Negative 48. Sorry, negative 24 plus 48 plus 8 plus 9, miss.
Mhm.
Um, yes, miss, I get 41.
All right, so that's how we know it's correct. All right, the last one, question 12. This is for Asar. All right, question 12. And we have 16W minus 60W plus 2W, and that is equal to 16 minus 8. All right, so go now, Asar.
16W minus 60W is equal to 44W. Plus 2 is equal to
Hold on.
46.
Positive 44W.
No, negative 44W.
Okay, plus 2.
Negative 42W.
All right, so negative 42W
Is equal to 8.
and 60 minus 8 is 8. All right. So what do we do from here?
W is equal to 8 divided by negative 42.
Okay, which is what? So we need to cancel that, right?
Yes, miss.
Okay, so what do we get?
2 into 8 goes 4 times.
All right, so 2 into 8, 4, and 2 into negative 42.
21 times.
Okay, so that's negative So negative 4 over 21. All right. So when we're doing algebra again, I think we'll be able to move on, factorize and then quadratic. So remember last week we did factorizing linear expressions, and now we are solving linear equations. So we're going to learn to factorize quadratic expressions and then solve quadratic equations. All right, so that's what we're going to be doing in next algebra class next week, Tuesday. All right, so thank you, scholars, for being with me. We're running late this evening. We're off to a late start. So thank you for still coming out and joining me. Those in the chat, thank you also for joining us, even though we started so late this evening. So tomorrow, we have another CSEC class at 8. So I'll see you then.
See you then, miss. Bye.
All right, so
Bye,
good
ma'am.
night, guys. Get some sleep.
Yes, miss.
All right. Hello, CSEC math students. I know you are busy preparing for your math test and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true. We'll be looking at the common errors that students make in the different topics in mathematics. If we know the errors before, we can certainly avoid making them. Are you ready? Come on, take my hand.